class. So first of all today I'd like to clarify why my hands are blue-ish. Well, you see here I got bored and found some old hair dye, and so that happened. It's supposed to be purple, but my hair's not bleached enough. Okay, so today we are solving quadratic functions using the quadratic formula. And if you recall, there's that handy dandy little song to help us remember. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. And so I'm going to sing that every time today, so sorry. If you recall from the notes, there was a bullet point that I skipped. We're also going to skip that today. That will actually be our last lesson that we'll do soon. So there's your quadratic formula. This can be used to solve any quadratic for x. So lots of the methods that we've learned, some only apply to a quadratic that looks a certain way, and we'll go over that in the future, but you can solve a quadratic function that's in standard form using the quadratic equation every time. If you take a look at example 6, I gave you some decimals. You really wouldn't want to complete the square with that one, with the decimals. You couldn't use the square root method. If you graphed, you'd probably have some more decimals. So the quadratic equation is your best bet for that one. All right, so we're just going to jump in today. The directions say to solve the following quadratic equations for x, write your answers in simplified radical form and as a decimal round to the nearest hundredth. I'm not going to require you to write them in simplified radical form. That's something you'll do more in Algebra 2. I might show you a couple on here, but I'm really concerned that you can get the decimal answer, those x values, the roots, where the parabola is crossing the x-axis. All right, so first of all, you need to make sure that your equation is in standard form with an a, b, and a c. So ax squared plus bx plus c. This one is. So now we can actually just plug the a value, which is the 2, the b value, which is 25, and the c value, which is 33, into that quadratic equation. So x equals the opposite of b, which is a negative 25, plus or minus square root. Under the square root is b squared, so I'm going to put that in parentheses because it could be negative sometimes, minus 4ac all over 2a. Okay. Oh, I could actually color code that for you. Let me do that real quick. X equals opposite b plus or minus square root b squared, b squared, b squared. Okay, this is maybe a bad idea, but I'll persevere. Okay, let's just a. C. All over 2a. Okay. This took a little bit more than I thought it would, but opposite b, okay, so I colored that in blue, plus or minus square root b squared minus 4a c all over 2a. So the ones that I have that are not purple, these are the numbers that you will be plugging in every time when you're using the quadratic formula. The purple parts are the ones that will stay the same every single time no matter what. Okay. So now, since you have a radical, we just need to basically simplify this whole entire expression over here. Always deal with your radical first. Okay, because you might be able to simplify the radical and then simplify some of the numbers that you pulled out of the radical with these numbers on the outside. That would be if you're simplifying the radical, but we are finding a decimal today as well. But always find your radical first. So in your calculator, if you type in 25 squared, put parentheses around it, okay? Because if your b value is negative, Whenever you square a negative, your answer is always positive. So put parentheses around it. You got 25 squared minus, and then what I would recommend doing is putting another set of parentheses and then do your 4ac all together, because it's minus the value of 4 times a times c. So we're subtracting 4 times a times c. Okay, so that's what that looks like in my calculator. Notice I have my b squared in parentheses and then minus 4ac in parentheses. Okay, and then once you hit enter, we get 361. So we have x equals negative 25 plus or minus 306, the square root of 361 all over 2a. You can also simplify that 2a part in this step if you would like. 2 times 2 is 4. All right, so from this point, what I would recommend doing is creating 2 separate answers. So we've simplified the b squared minus 4ac part, 361. What I would recommend doing is x equals negative 25 plus the square root of 361 over 4, and x equals negative 25 minus the square root of 361 all over 4. So I basically just split it into the plus and the minus for that plus or minus, because remember that's giving us 2 different answers. And if I'm just asking you to find the decimal amount, type that into a calculator. So we've got, make it a fraction, negative 25 plus the square root of 361 divided by 4. Okay, so when I type that into a calculator, I get negative 3/2. Okay, or that might be negative 3/2, negative 1.5 as a decimal. So you could leave it as negative 3/2, or you could leave it as negative 1.5. And either one would be okay. What you should notice about your answer is that there's no longer a radical. So were we to write this answer by simplifying the radical, what that means is that 361 is a perfect square. So the square root of 361 is 19. That's just one that's not on our list, okay, of the perfect squares. Okay, but that is a perfect square. So it would have been negative 25 plus 19. So negative 25 plus 19 is negative 6, and then negative 6 divided by 4 is negative 3/2, or negative 1.5. Okay, so then over here with the subtraction one, we now know that the square root of 361 is 19, so x is equal to negative 25 minus 19, all divided by 4. So negative 25 minus 19 is negative 44. Negative 44 divided by 4 is negative 11. So x equals negative 11. So here are your 2 answers, negative 11 and then that negative 3/2. Okay, so again, going back to that fundamental theorem of algebra, whatever your highest degree is, 2, remember that's your biggest exponent, that tells you how many answers you should have. Notice we have 2 answers for x. Okay, so there's an example of solving using the quadratic formula. Number 2, x squared plus 8x plus 16 equals 0. It's already set up in your standard form with your a, b, and c. So x equals opposite b, should be negative 8, plus or minus square root b squared minus 4ac all over 2a. And what you should notice, the opposite of b, so we want negative 8, plus or minus the square root b squared, so 8 squared, minus 4 times a. The leading coefficient of x squared is 1. Okay, c all over 2a, so we've got our 2 times 1. Hang on a second, the dog needs out. Okay, there we go. So now simplify our radical. We've got 8 squared minus 4 times 1 times 16. What? I got 0. So we have x equals negative 8 plus or minus the square root of 0 all over 2 times 1, which is 2. What's the square root of 0? 0. So really, x equals negative 8 plus or minus 0, but we don't need to write that part, and then divided by 2. What's negative 8 divided by negative 8 divided by 2? Negative 4. So we only got one answer for this one because that radical part gave us a 0. What you should know about this, because I did just reference the fundamental theorem of algebra and saying you should have 2 answers, but this is something that I talked about in class briefly, but if you don't remember, all that means is that you have a vertex that's on the x-axis, and in this particular case, it's at negative 4. Okay, and so then your parabola is sitting on the x-axis. The vertex is right there on the axis. So you only have one answer for x. This is just called a repeated root. Okay, so technically there are 2 answers, but it's repeated. It's the same value. Okay, so hopefully that one made sense there. Number 3, using the quadratic formula. Okay. Well, you can see that the fish is still alive well. It's all right, bub. Okay, example 3. 2x squared plus 6x minus 7 equals 0. Using the quadratic formula to solve for x. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Okay, you're plugging in your values. The opposite of b would be a negative 6 plus or minus b squared minus 4 times a times c all over 2a. Watch your signs. Okay, this time c is a negative 7. And so plugging it in, we've got b squared, so 6 squared, minus 4 times a times c. So 4 times a times c, which is at negative 7. And we get 92. So the value underneath the radical is 92. X equals negative 6 plus or minus the square root of 92 all over 4. 2 times 2 is 4. All right, now we can split it. 1 for the plus, 1 for the minus. X equals negative 6 plus the square root of 92 divided by 4. And I'll switch color up here. X equals negative 6 minus the square root of 92 over 4. Okay, so we've got our plus and we've got our minus. So negative 6 plus the square root of 92 divided by 4. I got the decimal 0.8979. So if we were to round that to the nearest, what does it say in the directions? Hundredth, tens, hundreds. We would have 0.89. Well, it was still rounded up to 0.90. Okay, so since we're rounding to the nearest hundreds, we want 0.90, making that 0 significant there on the end. Remember your significant digits. And then negative 6 minus, negative 6 minus the square root of 92 divided by 4. I get negative 3.8979. So negative 3.90 if we were around to the nearest 100th. Dog, in or out? Make up your mind, child. All right. So those are your two answers for example 3. What I want to show you next is same problem. Okay, those are the decimals, but what this would have looked like if we would have simplified the radical. So I'm going to do that over here in orange. So the square root of 92. What is the biggest perfect square factor of 92? You could go through and list them all out, divide them, but 4 is the biggest perfect square factor. So this becomes x equals -6 plus or minus the square root of 4 times the square root of 23 all over 4. Okay, so I'm over here. We are done with this, but I'm just showing you a little bit extra here. So then when you simplify your square root of 4, x equals -6 plus or minus 2 radical 23 over 4. Okay, so there is my simplified radical. I'm just simplifying the square root of 92, and that's the same thing as 2 times the square root of 23. So the radical part is simplified, it's done. Now you can look at all of your outside numbers, the 6, the 4, the 2, the -6, 4, and 2. Since they're all even, you can divide them all by 2, and what you would get is x equals -3 plus or minus the square root of 23 all over 2. Okay, so 6 divided by 2 is 3, 2 divided by 2 is 1, 4 divided by 2 is 2. That would be your simplified radical answer. Okay, and if you were to type that in a calculator, -3 plus the square root, oops, my fingers are not pressing the right buttons. All right, -3 plus the square root of 23 divided by 2. Oh, looky there. We get our 0.8979 blah, 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 which was this same number right here. So we do end up getting the same answer, it's just written differently. So that would be your answer is a simplified radical. This would be decimals. I'm okay if you just do the decimals. Okay, this is just something that you'll have to do eventually, probably in Algebra 2. So if you wanted the heads up there, you got it. You're doing example 4 on your own. The numbers are bigger, but that doesn't mean anything, okay? You're still just gonna plug them in, simplify, or do the part under your radical first, and then split it into the positive and the negative, plug it in, you got your answers. Number 5, I do want to show you number 5. So 3x squared minus 18x plus 30 equals 0. So using the quadratic formula, x equals opposite b plus or minus square root b squared minus 4ac all over 2a. So, something you should notice, b is negative, so the opposite of b here is positive, and then plus or minus the square root of b squared, negative 18 squared. It's a negative times a negative, which makes it positive, so you should not get a negative number there. So typing in the b squared minus 4ac, we've got negative 18 in parentheses squared minus parentheses 4 times a times c. Okay, you should get negative 36. So x equals 18 plus or minus the square root of negative 36 all over 6. Do you recall what happens if you have a negative under your radical? That is an imaginary number. So I left this one on here just so that you could see that it's still possible to get an imaginary number solving quadratic functions. So in a previous lesson, we took out the I. So let me just finish this one with you. I'm not going to do this to you on your quiz test, your take-home quest, but I just wanted you to see it. So x equals 18 plus or minus. If I were to take out the I, we would be left with the square root of 36. Well, 36 is a perfect square, which would be 6. The square root of 36 is 6. But with that I, so that technically leaves us with plus or minus 6i. Okay, so taking out the imaginary part, the square root of the negative 1, and then the square root of 36 is 6. And then all divided by 6. And then 18, 6, and 6, you can actually divide all of those numbers by 6. And so 18, yeah. Okay, a little bit of a brain fart there. Dividing all of those numbers by 6, you get 3 plus or minus I. 18 divided by 6 is 3. 6I divided by 6 is just I. And then 6 divided by 6 is 1. So that's like over 1, but you don't need to show that. So this just simplifies to 3 plus or minus I. That is a complex number, real, imaginary. Like I said, you don't have to worry about that, but I did just want to include one of those on there so that you know it is a thing. But like I said, you do not have to do this. Okay, and then let's do the last one together with the decimals, yeah. So, example 6, 6.4x squared plus 2.5x minus 5.9. By the way, I did make this a subtraction sign. It was positive, so make sure you fix that to a negative. If I left it positive, it would give you another imaginary number. So make that negative. So x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay, so opposite of b, negative 2.5 plus or minus b squared minus 4ac all over 2a. Okay, so do the part underneath your radical first, b squared. So parenthesis 2.5 squared minus parenthesis 4 times 6.4 times negative 5.9. I got 157.29. So x equals negative 2.5 plus or minus the square root of 157.29 all over 2a. So 2 times 6.4 is 12.8. So that's where we should be at now. We've got the part underneath our radical simplified, and now we can split it into the positive, into the negative, and then plug it in our calculator. So we've got x equals negative 2.5 plus the square root of 157.29, all divided by 12.8. And we have x equals negative 2.5 minus the square root of 157.29, all divided by 12.8. I put them in two different colors. Okay, so this is just the positive version, this is the negative. Calculator. If you do not do the fraction function on your calculator, just do it in parentheses. So your numerator, parenthesis, negative 2.5 plus the square root of 157.29, parenthesis, I'll show you this in a second, divided by 12.8. So if you don't use the fraction function, just put your numerator in parentheses. If there was more to the denominator, we would put that in parentheses too, but it's not necessary. And then enter, you should get 0.7844. So rounding that to the hundredths would be 0.78. This is one reason why the quadratic formula is helpful with those crazy decimals. And then if you have the negative version, you're subtracting the radical, you get negative 1.18, rounding to the hundredths. So that's all I typed into my calculator, all in one step. And there would be your two x-intercepts of your parabola. I hope that you've enjoyed this lesson. That is all for today, folks. You are doing example 4 on your own. And come back soon for the chart, which will be our last lesson. Okay? I hope you have a great day. Bye.